Okay, everybody. So this video here, we're going to, as it says, construct and simplify the difference quotient, which is f of x plus h minus f of x over h. And we're going to do that when f of x is equal to 3 over x squared plus 1. So the difference quotient here is an important first step in a calculus course. That's not our goal. Our goal here is simply just to practice playing with functions and working with function notation. But this is a nice little tool to use here. So we're going to evaluate this. We're going to plug this thing in here. So remember the way this works here. And I'm working with a slightly more complicated expression in this case than I have in some of the previous videos. am evaluating my difference quotient, first of all, f of x plus h. Now what f does is it takes what's inside that notation, those parentheses, squares it, adds 1, and divides that into 3. So in this particular case here, this is going to be x plus h squared plus 1. That's going to be the denominator of 3. That is f of x plus h. Minus f of x. Well, f of x is simply 3 over x squared plus 1. And then the difference quotient has this h in the denominator. Now, we are not done here. There is a very natural stopping point to the simplification here. It's going to be quite obvious when it happens, and I'll point that out when we get there. In the numerator, these two fractions here, without any numbers there, I don't know if there's a common factor that's not just the multiple of those two. So without that knowledge, I basically have to multiply the denominators together, which means I got to multiply numerator and denominator here by x squared plus 1. And I got to multiply the numerator and denominator here by x plus h squared plus 1, x plus h squared plus 1. Really no other way around it. So yeah, that's going to be a little bit messy. But, okay, we still got this h in the denominator. But what that means is my denominator in the numerator, which is kind of weird to say, but my denominator in the numerator is going to look like this. It's just the product of those two. Up here, that becomes 3 times x squared plus 1 minus 3 times x plus h squared plus 1. Ugh. Okay, lot going on. I might also want to consider this division by h here. Consider that to be division by h over 1, just so that you can see what it is we're about to do with that. So now I'm going to take my x squared plus 1 in the denominator multiplied by x plus h squared plus 1. I'm going to expand out that entire numerator. Okay, so this is going to be 3x squared plus 3 minus, now I'm going to do this in 2 steps because I want to make sure that everybody follows what's going on here. I'm going to expand out that binomial first. And that's going to be x squared plus 2xh plus h squared, and then there's this plus 1 at the end there. And then this is all going to get multiplied by the reciprocal. Okay, remember, I'm dividing by this h plus 1. I'm going to multiply by the reciprocal. Okay, I'm dividing by a fraction. So now my denominator is going to look like this. It's going to have an h in it. It's going to be x squared plus 1. It's going to be x plus h squared plus 1. And then up in my numerator, now I'm going to distribute this all out. I'm going to get 3x squared plus 3 minus 3x squared minus 6xh minus 3h squared minus 3. Ugh, okay. But we've made some good headway here because now watch what happens. 3x squared, negative 3x squared becomes 0. Positive 3, negative 3 becomes 0. Now that's fantastic. And it's really important because what that means is what we're left with in the numerator is an expression that has a common h to it. And if I factor that out, and I know someone's going to point out, well, there's more than just an h common there. There's this negative that I can take out as well. And that's true, but I'm really not interested in that. What I'm interested in is the fact that there is a common h, because this is my endpoint. I can cancel those h's. They're going to cancel, become a 1 there, a factor of 1. And so this becomes negative 6x minus h over x squared plus 1, x plus h squared plus 1. That's what I'm after. Now I know I'm done because I've canceled those h's there. There's still h's in my expression, but h is no longer a factor in the denominator. And in fact, you might even want to include that h cannot equal 0. We'll find in a little bit here that in calculus here, that actually doesn't become quite as important as it once was.